Hello everyone, thank you for having me here. It is an honor to be here with 15th International Conference on Soft Computing and Pattern Recognition. I, Viren Dani, representing as corresponding author from Sri Vaishnav Vidyapeeth Vishwavidyalaya, and my co-authors are Ms. Nisha Bhati from Medicaps University, Ms. Sneha Nagar from IIST, Ms. Aisha Mandloi from SKITM, and Mayank Matkar, a BTech student from SVV. Here, I am going to present a paper titled A Framework for Recommending Products to Solve Cold Starts Problem Using FP Growth Algorithm. The entire presentation containing different slides which describes our research work. Next slide is abstract which will give short overview over this paperwork. Different product characteristics and consumer expectations must be analyzed when making a product or service recommendation based on use. However, if all types of knowledge are inaccessible, this is known as a cold start problem in a recommendation system. To explain and address the issue of cold start, this paper suggests a structure for user experience based product recommendation. As a result, this paper introduces a four-phase recommendation scheme, that is, web users data analysis, primary recommendation, users current search, and final recommendation. The result shows that the prediction is accurate and precise. Furthermore, compare result of proposed system to traditional system using a priori algorithm. Data mining is distributed in several different domains of engineering and science according to the use and applications of data mining techniques that are termed according to the application, that is in text analysis it is termed as text mining. In web data analysis it is termed as web mining and others. In this presented work, web mining is the key area of investigation and application design. In this proposed work, the web usages mining. In this presented work, web mining is the key area of investigation and application design. In this proposed work, the web usages mining and the web content mining techniques are used for designing a web recommendation system. The web mining consumes the web data in the form of web access logs, web pages content, web page links, and others. The web recommendation system is a classic test and analysis area that is continually improved day by day. The aim of the recommendation system is to propose a service or product to the end user based on their actions and specification. In the cold start issue, the web application or suggestion framework does not have any previous knowledge of the user's habit or web navigation behavior, so it must make predictions on the most appropriate service and product based on their existing web use patterns. Since the recommendation engine has little data on the end user, the chances of making a correct prediction are slim. In this, a new behavior analysis based recommendation model is suggested, which aims to improve predictive accuracy with minimal data. In this sense, a new behavior analysis based recommendation model is suggested, which aims to improve predictive accuracy with minimal data. Yengu suggested an immersive customized recommendation framework based on a mixed algorithm paradigm with the goal of making e-commerce shopping easier and avoiding knowledge overload. Dan Zeng suggested an efficient cross-border e-commerce customized advice model that incorporates fuzzy association rules and diverse preferences. Veer Du presented a system model that allows several parties to work together to train a learning model across remote datasets while maintaining data source privacy. Bo Kaiye created a hybrid scheme and extended it to a review paper recommendation. This approach has both content-based and shared filtering advantages. Pradeep Kumar Singh suggested a method for recommending an object to a target customer based on top K similar neighbors' preferences. This section includes the different techniques and applications that are developed recently or implemented to improve the association rule mining techniques. The figure 1 depicts the analysis of web usage for a proposed work design. In this phase, the web usages data is consumed, therefore, the web access log is accepted as input to the system. The web access log is generated at the web server and where the data or application is parked. The web server maintains the entry on a log file for each request and response to the application. Web access log file contains several different attributes such as user IP address, timestamp of user request and response, protocol information, web methods, resource name, and others. All the data available in the web access log is not utilized with the recommendation system design. Therefore, the pre-processing techniques are adopted to remove or clean the unwanted data from the web access log. After pre-processing of data, the target attributes such as the user IP address, resource name, and the timestamp are preserved in the web log, and remaining information is removed from the file. The remaining information is transformed into a relational table for utilizing with the further processes. The FP growth algorithm performs frequent pattern mining on the data. The frequent patterns are the subset of the entire set of the data which is selected based on the frequently available attributes. After computing the frequent pattern, the user's first activity or initial search product is considered. According to the user search product and the available frequent set, the similar set of data pattern is concluded as the first stage prediction. The first state recommendation is just based on the user search data and the available frequent item which is considered for recommendation. After first stage of the prediction, the search space is reduced in the next phase of recommendation. The above diagram 3 demonstrates the second stage of prediction. In the first stage of prediction, user can select some products according to their interest. The interested products are recognized here as the user click events in the product suggested in initial prediction. The selected product by the user and the web access data is used here with the KNN algorithm for finding the similar kind of patterns in weblog history. Here, the user product selection behavior can be matched with the other user's product selection behavior. Therefore, the similar behavior based products are suggested in this phase as the second stage of recommendation. The aim of this module is to make predictions by using collected information from the last two stages of predictions. The aim of this module is to make the predictions by using collected information from the last two stages of predictions. The figure 4 shows the narrow down the search space for making precise prediction for the end user. Basically, the second stage of prediction contains fewer amounts of data than the primary prediction. But the second stage of prediction also contains a significant amount of data to predict the appropriate product to end user. Therefore, based on computed additional information, the accurate prediction tried to make. The list of products is collected which is obtained in previous stage and three factors are concluded. First, the price range of a product which is purchased by the different users and having similar behavior of product selection. Secondly, the brands of products which is accepted by the similar behavior users. Finally, the reviews of the product are considered which is extracted from the social media. All the computed factors are combined to rank the list of recommended products in second stage. Additionally, based on the ranking of these three factors product are recommended to user. The proposed algorithm. Firstly, we will take the input weblog access as W and initial search query Q, and we will get the output recommended products RP. And the process is described as follows, which returns the recommended products RP. In the second stage prediction, we will give the input as first stage of prediction, which is represented as capital R, capital P, and the pre-processed data which is represented as capital P subscript n. And we will get the output as second stage of recommendation, which is represented as capital S, capital R. At the final stage prediction, the input will be second stage of prediction, which is denoted by capital S, capital R, and we will get the output as final recommendation, which is denoted by capital R. Accuracy is a measurement of correctness of prediction in data mining and machine learning. This is the ratio of correctly recognized sample and the total samples to be recognized. The graph is as follows. Error rate is the measurement of incorrectly predicted outcomes among the total samples produced to be predicted. Conclusion. In a recommendation system, a cold start is a major issue. According to the issue statement, the advice framework lacks any knowledge about the product or end user behavior that could be used to make a prediction. In this case, extra work is required to extract the information about the product and consumer experiences to make reliable recommendations. In this case, a data model with 4 key phases is proposed. First, the site utilization data is examined and pre-processing is carried out. This information aids in the comprehension of other users' behavior and the identification of users that behave similarly to the actual users. Following that, the FP growth algorithm is used to do regular pattern mining. Without some previous knowledge of the user's behavior or the substance, this step-based forecast helps to allow more reliable predictions or the recommendations. The aim of the proposed research is to address the cold start issue in recommendation system design. As a result, a model is applied and tested, and the new approach is suitable depending on the experimental review. References are as follows, which was included to prepare the entire proposed work. Thank you all for listening me patiently.